Hi, I'm Robin Lobel, creator of TorchStudio. TorchStudio is a graphical user interface for PyTorch, allowing all PyTorch interactions such as loading, formatting datasets, debugging, training models in a user-friendly way, removing most of the coding burden and getting instant visual feedback. It can work both as a standalone software or as an extension to your favorite IDE. If you don't already have one, TorchStudio will set up a Python and PyTorch environment for you. You're then ready to load your first dataset. As a basic example, we're going to load the NIST dataset, composed of handwritten digits and their interpretation. It's as simple as selecting the TorchVision datasets category, then the NIST dataset, and clicking Load. TorchStudio will automatically download the dataset and show it to you. As inputs, we have pictures of handwritten digits, and as targets, we have the corresponding interpretation of those digits. For now, let's leave the default formatting as is, and let's run an optional analysis of the dataset by clicking Analyze. It will scan the whole dataset and break down its composition. As we can see, the dataset is well balanced. All 10 digits are almost equally represented, and the order in which they appear in the dataset is pretty random, so there's no need to reformat. Now that we've loaded the dataset, let's create a new model by clicking the plus sign at the top. This will create a new tab. Each tab represents a model. TorchStudio provides a model which can learn to classify pictures from this dataset. It's available in the TorchStudio Models category, and it's called NIST Classifier. This model comes from the PyTorch tutorials, and if needed, we could see and edit its source code by clicking Code at the top. But for now, let's just build it as is by clicking Build. This will display its graph representation, showing what nodes it contains, how they are connected to each other, and how tensor size changes from one node to the next. We feed it with monochromatic pictures at the top, with a resolution of 28 by 28 pixels, and at the end we get 10 possible values. For now, the model knows nothing about classification. That's why for any digit picture will show it, it can only say there is an equal chance it's any number. It's time to train it. Let's leave the default hyperparameters as is and click Train. If you didn't set up a remote training server, it will use local hardware to train it. In this case, the metal acceleration of my Mac. As training progresses, we can monitor loss and accuracy metrics on the right side of the screen. The most important one is the accuracy. As long as it keeps improving, it means the model is properly learning. And this is reflected in the predictions of the model. As we show it different digit pictures, including pictures from the validation datasets that it never saw before, it now properly predicts the correct interpretation. When the training completes, which is when it can no longer improve the accuracy further, we can export our trained model in different formats, as model weights, or as TorchScript or RNX file containing both the model and its weight. These models can then be reused as is in production, such as Python scripts, desktop applications, or web services. Now let's move on to a more advanced example, involving a custom project within an IDE, a remote training server, and exploring the hyperparameter space. To install IDE extensions and set up remote servers, click Settings in the TorchStudio menu. To add a remote server, click Add, give it a name, enter its address, username, and password or key file. It works with any server, on-site servers, cloud instances such as AWS, Azure, Google Cloud, and any operating system. If the server doesn't already have a Python or PyTorch environment, TorchStudio can remotely install and set it up for you. We'll then install the extension for the IDE, in this case Visual Studio Code. All we have to do is click Install VS Code extension. We can now close TorchStudio. Let's launch our IDE and load our Python project. This project contains a custom dataset and a custom model. Let's add a TorchStudio training to it by right-clicking on the project and clicking New TorchStudio Training. Then click on that new file to open TorchStudio. Let's drag our custom dataset from VS Code to TorchStudio and click Load. This is a dataset made of spectrograms. The goal is to teach a model how to remove reverb in an audio recording. To achieve this, we've prepared different audio recordings on which we've applied reverb, which will be our inputs. and the targets are the original audio samples without reverb. To speed up training during this demo, let's use only half of the dataset. Now that the dataset is loaded and formatted, let's create a tab for the model. Then drag and drop our model from VS Code to TorchStudio and build it. We can see its shape as a unit. Let's train it with the default hyperparameters by selecting a training device on our remote server and clicking Train. As the training for this model starts, let's duplicate this tab by clicking on the plus sign. This time we'll change the depth of this unit by changing its depth parameter and rebuild it. As you can see, its graph representation changed, reflecting the deeper layers and connections. Let's train this one too. As the training is already in progress on this remote device, it will wait for the previous training to finish before launching this one. Finally, let's make a third copy of this model, and this time let's change the loss function from mean square error to mean absolute error, and queue that training too. Now that we've explored the hyperparameter space for that model a bit, it's time to compare what parameters actually improve the training performances. Let's move to the dashboard at the top right corner. The dashboard shows you all the metrics and all the parameters differences from all your models at once, so that you can easily identify what makes a positive difference and what model performs the best. In this case, this combination seems to work best, producing the highest validation metric. So we'll switch to this tab and export the weights. The weights will be immediately available in our IDE project, and then all I need to do is create the model with the corresponding depth and load its training weight. It's then ready for inference in my Python project. I hope you enjoyed this presentation. If you'd like to know more about TorchStudio features, please visit torchstudio.ai for videos, tutorials, and more.